Bismillahirrahmanirrahim. So today our topic is artificial neural network. What is the basic idea about that one? The basic idea is to solve some complex and non-linear function, which has some hard to solve by the no, by the classification problem. Right? So artificial neural network is the is the collection of different nodes with the different layers. It is just like working like in a human mind or human brain. Then how the human brain is working is like analogous to that one. So they have nodes and they have edges. Okay, so these nodes and edges are resembling with the human mind. Like for example, human mind has a signals which is resembling with the edges, right? And there is perceptron. So these like analogous to the human mind. So this artificial neural network is solves complex problems which is not solvable by the normal algorithms. So let's see how it looks and how it is what is the function and how it is looking in a mathematical way, in a graphical way. If you look at the on this side, on the left hand side, what we have it, if you see over here, this if you look at this diagram, there we have these this is the input, we have it here, and here is the output, we have it. And these are the weights on the edges, right? These are the weights on the edges, right? And usually we multiply these two basically to get the y, right? So this is a single layer, artificial neural network, or we call it perceptron. Okay, and when sometime we combine many these kind of layers, which we call a multi-layer, so which you will see this thing in in the upcoming slides, right? So usually it generates activation functions for the next upcoming layer, right? So for example, if you want to activate the next layer, you must execute this function, and that function is called activation function. There could be many functions which is called sine, sigmoid, 10h, and variants are available over there, right? And some complex activations are, which is being used by the in a real life, that is called max and relo. These are very highly used in a artificial neural network. So here the output is usually, like you can see over here, 1 and minus 1, you can see over here, by using these formulas. If we will have some more examples, then we will illustrate that how this formula basically working, and how it help us to find out complex problems. Now this is one of the example of a single ANN, or which is called perceptron. So, and we use a black box. So the black box is the one in which you don't care what is going inside. Like for example, here if I just make it clear for you, like for example here, whatever the formula you use, whatever the function you use, right? We are not concerned about that one. So that is called black box terminology. In software engineering, we also use that one. And if you look at here, these are the inputs, and that is the output, right? Okay. So let's suppose, for example, what is the logic we have made over here. If you see here, one, there is one, we're interested in this one, here is a one, okay, and here is a one, okay, and here is a one, right? So if you look at this one appears only when we have and out of the three values, if we have two ones, so then we get a one, right? See over here. And if there are single one, we get minus one. Okay, usually in binary we have 0 and 1, but in in artificial neural networks, we categorize as 1 and minus 1 because of the function sign functions. Okay, now let's see the next slide, what we have it. Now here in this black box, if we see over here, now we are opening the black box and we are putting some values inside it, and so each weights is 0.3 over here, and if you multiply the weights with the inputs, so if you see over here in this example, we are multiplying weights. These are the weights, 0.3 on the edge x1, okay, and this is 0.3 on the edge x2, and this is 0.3 on x3, okay, and this is like, the constant we have it, right? So by this way, we are, if we apply the sign functions for the activation, so either we get like, 1, or we get like -1, okay. So according to this one, what is the logic used over here when we get like, 1? So we get the one whenever the two values are 1 1, right? So here is also two values, any of the two values is 1 1, any of the two values among the x1 x2 and x3 is 1 1, okay, and similarly here, right? So if we have only one, for example, and 2 0, then we get -1, right? So I think this is very simple logic over here. Now let's go to some more complex example over here, what we have it. So there is a like a learning rule. Usually at every layer, the artificial neural network, it gets learned from the previous layer, right? So when it learns from the previous, like, mistakes, or from the previous error, like human are also learning. Every day is a learning for the human. They learn from the previous day mistake, and then they go forward, right? So, and they are trying to minimize their mistakes, right? Similarly, artificial neural network, they are also learning from the previous errors, and they're improving the errors, and they're improving the weights, right? If you see over here, so weights is 0.3, so next maybe in the layer, maybe the weight decreased to 0.2, or maybe the weight increased to 0.4, right? So they are learning and adjusting the weights, and then we are getting our desired outputs, right? So so we need to initialize the weights. What are the weights? This is very important. So for the perceptron learning rule, and then we repeat. We constantly repeat and see, like an x1 and y1. Okay, and this is basically the normal algorithm without the code. So when I say algorithm, it means this is basically code, but not in a Python, or not in a C language or Java language or any language, but it's just like, for your understanding that how this code will work, how we initialize the values, right? How, what will be the y, what will be the w, what will be the lambda, okay. So lambda is very important. So this is learning rate, right? So every layer we are learning something. We are learning for the next layer, right? If you have a 10 layers, so after every layer we are learning, and we are adjusting the weights so that we could have a desired output. So what is the k here in this one? K, w already we know it's a weights, right? And y is our desired output, right? and uh, and then like y, like in the cap y is the previous value, right? So the previous values comes to the next value, and it gets like, repeating, right? So here we minus the new values, okay, the new output with the previous output, and with the iterative value as well within the power, right? And k is what? K is the iteration number. Iteration number means if you have a 10 iterations, right? So it will be, or 10, we call it like, epochs, right? So it will be like, for example, here will be k value will be 10, right? So it will start from like, for example, 1 2 3, or sometimes we start with the 0 1 2 3 up to 9, or if you start with the 1, it will be from 1 to 10. So like, logically we start from 0 basically. Now here you see the same weight concept. We have like w is a weight, right? And y is the output, k is the iterations, right? And x is your input, right? So if you see over here, weight update formula, that how we update the weight. So according, if you use this formula, you have to feed this formula into the Python code. I will show you some Python code, like, in the next video, and how the Python codes, they take these values and they adjusted it, right? And then they have like, updated weights according to this formula. So you minus the previous weight with the new weight, right? And so if your, like, previous weight, previous output, and then the current output is same, so there is no error, right? So there is no error 0, so there is no update needed, right? If it is, your new output is greater than the the previous output, then the error is 2, for example, by calculation, weight must be increased. So it means that you need to increase your weight, right? Okay, assuming xij is the positive, so y will be increased, y dash will increase. Okay, in case, okay, this is like, for example, if your new output is less than the with respect to the old output we categorize as a y cap, right? So it means the error is -2, so weight must be decreased, right? So sometime here in this one, when it is like greater sign, you have to increase the weight, right? When it is less than sign, you have to decrease the weight, right? So assuming xij is the positive, right? It's positive means like it's a all the values are x are greater than 0. Okay, so that y will decrease, right? So this is like, generic rules for learning. Okay, now let's see. Now let's go to the next slide, how we do it. Okay, here lambda is 0.1. Okay, so as we talk about the lambda, lambda is the learning rate, that how we are learning, right? So if we are learning, so there will be change in the lambda, right? So here let's suppose we are for example learning from the, what do you call it, from the previous layer. Okay, for example, the learning rate is 0.1, so it means almost 10%, right? You are learning 10% from the previous layer. So here, according the rule, as I showed you, this is exclusive OR. So like, XOR, for example, this example is XOR. I just write for you as a example, exclusive OR. So I told you if there is 2 1, okay, the output will be 1, right? So if it is less than 2, so output will be -1. Okay, so similarly you can see over here, this is +1, this is +1. Why? Because there is 2 1, right? And there is like, -1, because there is only one, one time one is repeated, right? So now look at this one, weights. So there are different weights. So in the first iteration, for example, we have like, 8 iterations or 9 iterations, because if you're starting from 0, so total are 9 iterations. So initially we assign 0 weights. When the second iteration is 0.2 and 0.2, because and then in this one it is decreased. Why? Because as per the previous slide, the y is less than the y is less than y lambda, so we have to decrease it, right? Now see here, here the W3 is increased, right? This is also increased. So weight updates. So you are updating the weights over the first epoch. So first epochs is a very historical terminology. Epochs means like, thousand and millions of years is called epochs, right? Usually it's historically, but here epochs means when you complete one full iteration for the neutron, for the perceptron, like we call it the epoch, right? Okay, so we have one epoch, second epoch, third epoch. So with every epoch, your learning is increased. So see over here, so this is, let's suppose this is your first epoch, right? So this first epoch is, let's suppose it will go here. Okay, this is your second epoch. Okay, this is your third epoch, right? This is the fourth epoch, and five and sixth epoch, and seven epoch. So if you don't include it, the first epoch, then it will be six, right? But if you include it, so total will be seven. So weight updates over all epochs, right? So this is like, all the epochs. So to, you need to clarify what is epochs. So epochs is the repetitions of full repetition of your of your neural network, right? Now look at this one. This is another example of perceptron learning, and here it shows you the linearity, that if y is a linear combination of the input variables. If your inputs, like for example, you have three inputs, I just like, just highlight for you the inputs over here. Like for example, you have x1, you have x2, right, and you have a x3 on the z-axis, right? So this is your x-axis, this is your y-axis, and that is your z-axis, right? So according to this one, since y is a linear combination, so y is your output basically, right? Based on your three inputs. So So what is that one? Y is a linear combination of input variable. Decision boundary is a linear one, right?